This notes video is on distributive property. We're going to talk about how you can go about solving the same problem two ways. In our first problem up here, a set designer has two pieces of plywood, one with the dimensions of 3 by 4 and the other with the dimensions of 6 by 4. Now, if we wanted to find out the total area of this plywood, we could simply do 4 times 3 plus 4 times 6. Okay? And we would come up with the total area of these two pieces of plywood. If we put the two pieces of plywood together down here, now we have dimensions of 4 for the width, and then we have 3 plus 6 on the top. 3 for the first piece plus 6 for the second piece. So we could write that equation out. 4 for the width times the length, which is 3 plus 6. Okay? So when we look at these two equations, these are expressions. These are equivalent expressions. 4 times 3 is 12, plus 4 times 6, which is 24, for a total of 36. But when I solve this one down here, do what's in parentheses first, this is 9, and then 4 times 9 is also 36. So it really doesn't matter which expression I use, I'll get the same answer. And so these are equivalent expressions. So I could do 4 times 3 plus 4 times 6 and come up with the same answer as 4 times 3 plus 6. That is called the distributive property. I would distribute this 4 to be multiplied times the 3, like I did up here, and then times the 6, like I did up here, and keep the addition in between. I distributed that 4 to these other two numbers and the multiplication that goes with it. So what is the sum of areas of the plywood when separated by space? We just found it's 36 feet square. And when it's placed side by side, it's also 36 feet square. Okay? So these are equivalent expressions, and it's an example of the distributive property. So when we look at this, if we want to do the complicated algebraic expression, if we have the numbers represented by a, b, and c, then a times b plus c will get the same answer as a times b plus a times c. We're distributing the a to multiply times the b, and we distribute it to multiply times the c, and keep the addition. It would be the same thing for subtraction. We distribute the a times b and a times c, and keep the subtraction in the middle. Okay? Looking at these down here, we're not going to do these examples. All right, if we were going to distribute the 5 times this expression, let's talk about it a little bit. First of all, I want you to notice that in the parentheses, which is what we would normally do first with PEMDAS, we can't really do any calculations.
Football players. So football guys, listen up.
All right, so there's nothing that we can actually do inside these parentheses. Because this is 2x, we can't subtract 3 from it until we know what x is. So what we're going to do is go on to our next step, which is multiplying 5 times what's in the parentheses. Now, according to the distributive property, I can do 5 times 2x and 5 times 3 and keep my subtraction and get the same answer, okay, as if what we knew was x. All right, so we do 5 times 2x, that makes 10x. We keep the x. Okay, 5 sets of 2x. So if I had 2x and 2x and 2x, 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 add them all up, I have 10 x's. So that's 5 sets of 2x, 5 times 2x. Then I distribute 5 times 3, and that's 15. Okay, I'm going to keep my subtraction sign. All right, so now I have 10x minus 15. That is the solution to this expression. It's not set equal to anything, so we can't solve for x. For the next one, I'm going to distribute my -2 and multiply it times the 5 and times the x. So I'm going to have -2 times 5 is -10. -2 times x is -2x. And we can keep the addition in there if we'd like to, or we can just call it -10 minus 2x. Either way is fine on these expressions. Okay? Any questions on that? We'll answer some of those tomorrow. We're going to do some more examples here. Here is what someone wrote. -8 times, open parenthesis, 5 plus 4, close parenthesis. They said that it was -40 and +32, and for a total of -8 at the end. Describe and correct that error. Now let's talk about solving equations when they have a distributive property and they also have the equals with the number. That's not an expression anymore. Now it's an equation. It's set equal to something. So we'll finally be able to solve for x on these. Let me show you the first one. I'm going to distribute this 5 to the 3x and then to the 8. So 5 times 3x, that's 5 groups of 3x. That's a total of 15 x's. And then 5 times 8 is 40. I can keep that plus sign. It's a positive 40. Equals 175. Now my next step would be to solve this as a two-step equation. So I'm going to subtract 40 from each side and then divide by 15. So that ends up with 15x equals, this is 135. Now if I take 135 and divide it by 15, let's see, let's try 9. Yep. So that's 9. X equals 9. And I had to divide by 15 on this side and divide by 15 on that side for x equals 9. Now for the check, we're going to plug this 9 back in where x was in our original equation. So I'm going to write out 5 times 3 times 9 plus 8 equals 175. 3 times 9 is 27. 5 times 27 plus 8. Sorry about that, my Bluetooth lost connection. Okay, 27 plus 8 equals 175. And then this is 35 times 5 equals 175, and we end up with 175 equals 175. And our check is complete. For the second one, actually I'm going to have you do number 2 by yourself. It's very similar to the first one. Let's talk about the third one. This is 20 minus 2x plus 7. All right, so since this negative sign, remember subtraction and negative are the same thing, since this negative sign is out here on the outside of the parentheses, that normally would mean that I would subtract the result of this parentheses. We have to pretend that there's a 1 here. Okay, this is -1 times 2x plus 7. So what we're going to do here is use our distributive property to distribute -1 to both this one and this one. So we're going to start out with 20 for our next part of the expression. Now we have negative 1 times 2x, which becomes negative 2x. So I have minus 2x here. Negative and minus mean the same thing. Then negative 1 times positive 7 is negative 7 equals 14. Now I have like terms that I can combine. I can combine my 20 and my negative 7. Remember, when you're combining like terms, the sign in front of the number stays with it. So this is 20 minus 7. That's 13. I still have a negative 2x here, but I have 13 positives left over after I combine like terms, and that equals 14. Then I can subtract my 13 from both sides. Okay. I have negative 2x equals 1. And I divide by negative 2, divide by negative 2. Okay? I end up with a negative 1/2. So negative 2 over 1 times negative 1 over 2 does equal 1 on this check. Remember, you multiply straight across, that gives me 2 over 2 equals 1, and that's 1 equals 1 for my check. Okay. Now, I want you to go ahead and try the word problem on your own, and we will talk more about this tomorrow.